This is Precalculus video 38A, limits and limit notation. So for our last set of videos of the year, we're going to be looking at some problems that you'll see at the beginning of calculus involving something called limits. And our first step is to get used to limit notation and what it means. So typically you're going to see an expression like this, where A and L are numbers and F is some kind of a function rule. And so when you see the limit as x approaches some number a of some function f equals some number L, the way you want to think about that is as x is getting closer and closer and closer to a, the value of the function gets closer and closer and closer to L. This will make a lot more sense with a couple of examples. So let's jump ahead and look at 3 examples of limits. All right, our first example says the limit as x approaches 2 of the function 3x minus 10 equals 4. Now, you might think that I can just plug in 2 for x and get my answer. And in this example, and actually the other 2 examples, that works. But what you really want to think about is not x equaling 2, but rather x being really close to 2. That will become important later on. So a better way to think about this is to think about numbers like 1.9 and 1.99 and something that's really close to 2. So when you do that, you get 3 times a number really close to 2, which gives you something really close to 6. And when you have something really close to 6 and you subtract 10, you get something really close to -4. So that may seem like a roundabout way of thinking about things, but that actually is a really important way to think about and consider limits. All right, example 2, same thing. When I approach -3, I don't want to think about -3 itself, but numbers near -3. So something like -2.999, when you square it, is going to be very close to 9. And so we say the limit as x approaches -3 is the number 9. Okay, again, you're probably seeing, can I just plug in -3? And in this example you can, but we'll see in another example that doesn't work. All right, last example is x approaches 10 of the following function. I get 123. So it's not when x is 10, but when x is close to 10, you get something that's close to 100 minus something that's plus something that's close to 30 minus 7. So when you put all that together, you get 123. All right, let's take a couple minutes and try a couple on your own. Give your best shot as to the answers to these 2 U-tries. All right, for the first one, again, you want to think about numbers near 6. So your answer is going to be close to -12, and you're going to add 5 to that. And so hopefully you got -7 as your answer. And when I plug in to the second one, -4, or numbers near -4, you're going to get numbers near 16. And you're going to be subtracting numbers that are near -8. And so that ends up being 24.